This video has been sponsored by Nuage Networks. For more information on the Nuage Virtualized Services platform and how Nuage is delivering consistent policy-driven automation across data centers, the WAN, and branch locations everywhere, please visit nuagenetworks.net and follow us on Twitter at Nuage Networks. We hope you enjoy the session.
After watching this video, visit ipspace.net/sdn to learn more about software-defined networking and overlay virtual networks. We went through a number of elements that any scalable overlay virtual networking solution should have. From the architectural standpoint, we should have distributed forwarding plane both on layer 2 and layer 3. Control plane should have scale-out architecture that allows us to connect multiple controllers together. There should be at least some distributed layer 4 services, particularly in security, hopefully also in net space. And the security mechanisms have to be scalable so that when we start deploying large tenant workloads, we don't hit performance limitations. And now, stepping back a bit, when you design your cloud infrastructure, start with the services. And once you have the service definition ready, then you can start defining the infrastructure requirements. What connectivity will I offer? What security will I offer? What performance will I need? How will I integrate with the legacy data center infrastructure? And how will I integrate with the WAN networks? Based on these requirements, you select the orchestration system that will support the services that you want to offer. Based on the orchestration system, you might be forced to select one or the other hypervisor platform. And based on those, you select an overlay virtual networking solution that will support the things that you want to offer. First, it should be easy to integrate with the orchestration system. It should have some scalable implementation of the network services, as I mentioned on the previous slide. And finally, you should be able to integrate it easy with the external networks. Whatever external networks you have. Maybe you have to integrate it with the MPLS VPN that you are already running, or maybe it's good enough if you can just connect existing VLANs to the overlay networks. That's more or less it for today. And now let's go through all the outstanding questions. Here is one that came in during our discussion of NAT. Does the hypervisor run any routing protocol? How will an unknown host, because we were talking how the traffic to unknown hosts is sent through the NAT rule. So how will the hypervisor know what an unknown host is? How will it figure out what is internal and what is external?
Yeah, so the controller, the VSC in other words, has the routing information, knows all the hosts in the internal networks. It knows, for example, which hosts are already in VMs, or if it learns routes from an MPLS or a PE type of device about other networks that are connected to the virtualized networks, let's say, then these are known routes and packets are forwarded without NAT. On the other hand, when it learns routes from the public network, then if the longest prefix match hits these routes, then the packet will be forwarded with a NAT. So adjusting whether NAT is going to be performed or not depends on whether the route was learned from the public VRF network or whether the route was learned from the internal VRF network.
There are a number of questions about running VSP in vSphere. Is that supported?
That's an interesting question. Yes, VSP is running in vSphere as well. As people know, VMware doesn't have an open API for the Esxi hypervisors for anyone to install a kernel module there. So we actually went around this, though, by creating an interesting combination where packets from the VMs are routed to a VApp that is actually implementing the VRS functionality. But then instead of the VRS sending the packets back to VMware and the vSwitch, we use SRIOV or PCI pass-through to directly send the traffic to the NIC. The problem in an ESXi environment is that the VMware ESXi switch is limited to about 1.2, 1.3 million packets per second. That's all it can do. So if we would route the traffic twice over the VMware ESXi switch, we would have a significant performance issue. However, with the trick that we are playing, where we are attracting the traffic from the VMs to the VRS, and then from the VRS we use PCI pass-through or SRAOV, we minimize that overhead. And so with about one core VM or maybe two core VMs, depending on packet sizes, in most cases we can hit the 10 gigabit throughput without a problem.
A question on security groups. We are using BGP communities between the VSCs to identify the security group memberships of individual IP and MAC addresses. But when you have to pass this down to the hypervisor through OpenFlow, are you using proprietary extensions or are you just using smart combination of OpenFlow matches?
Yes, the OpenFlow protocol actually has vendor extensions. So in order to pass this aggregate information, we have to utilize the vendor extensions because things like BGP communities are not supported by the common OpenFlow attributes.
Here's a question on the hardware gateway, or more of a comment. Yang models are coming, so eventually netconf and Yang would provide unified way. In principle, I agree with you, but in practice, it might take forever. Or are you more optimistic, Dimitri?
I mean, my perspective is we will use whatever the majority of the hardware switches use. So it's a matter of how the market and the ecosystem evolve. I don't think the protocol makes much of a difference. I think the question is how can we find the maximum coverage in terms of hardware platforms that support the corresponding protocol. So that's the main driver here.
An interesting one. Is there any reason why Nuage used XMPP between VSD and VSC?
That's actually a very good question. In theory, one can use any pub-sub, public subscribe type of interface, and we went a lot back and forth on this. What you will see coming from Nuage, though, is also a federation of VSD controllers, and VSD, essentially, the policy plane can be federated as well. And XMPP provides federation capabilities for free. It's a federated mechanism to begin with. So that's why we chose XMPP from the beginning on, so that we can have this type of federation of policy systems as well down the road. And the way you can think about it, and I use this analogy all the time, is like a wireless network where a VM is like a cell phone, that it has a home service provider and it has a remote or foreign service provider. And the two service providers can use a federated control plane like XMPP in order to exchange information.
This goes back to our discussion of overlay and underlay integration and routing protocols. How does overlay networks deal with underlay constraints, for example, bandwidth availability? My typical answer is they assume that all the endpoints are equidistant, and if you don't provide that, you've violated the implicit contract, so you better fix your transport network. Do you have any better answer for this?
No, that's a good question, right? So we have to understand the difference within a data center environment and across data center environments. I think it's becoming apparent, and it's common practice right now, that within a data center environment, points are equidistant. This started with an excellent paper by Albert Greenberg and the Microsoft guys 4 or 5 years ago. If people see the Facebook architecture that Facebook published just last week, and it's actually a very interesting scale-out or scalable data center infrastructure architecture, then you will notice here very fast that in reality, within the premises of a data center, people avoid oversubscription as much as they can, because that's the easiest way to scale it and not worry about it. And now when we go in between data centers, the answer is similar to what people would do with MPLS networks, right? So when we are talking in between data centers and we are talking about VRFs between data centers, one would have to do traffic engineering in between the data centers and use proper MPLS behaviors over there. So I think that's the two different use cases. I don't think we can lump them together in one.
I Totally agree with you. And now what seems to be the final question. Should you be worried about the scaling factors of the gateways? For example, in the layer 3 case, all entries on the gateway like ARP entries have to be present. So the table sizes definitely matter. That's absolutely right. Obviously, you cannot go beyond the hardware capabilities. If you're running layer 2 gateways, you will be limited by the number of MAC tables. If you're running layer 3 gateways, you will be limited by the number of host routes and ARP tables. However, what you can do is, because you can integrate straight with the MPLS VPN network, maybe the ARP entries and the host routes and so on don't even have to be visible on the hardware gateway. They just have to be visible on the PE router or maybe even on the other side of the MPLS VPN cloud. So you're pushing the scalability problems further out, and by that you're reducing them. And I know, Dimitri, that you have another scalability feature that helps you scale the gateway. So can you tell us more about that?
There are two things with the gateways. Obviously, the ARP entries and stuff like that towards the data center, one has to accommodate the hardware limitations. In most of popular top-of-rack switches or gateways, hardware gateways, for example, anything that uses the Trident 2 chipset right now, the number of ARP entries or host routes is on several hundreds of thousands, is more than 100,000. So that allows you to scale pretty well in a lot of the data centers. And then there is the other thing that is important is, what do you advertise from the gateway outside towards the rest of the network? And that's where you have to use BGP techniques in order to aggregate routes and not advertise host routes to the rest of the network, right? So the gateway has to do aggregation and advertise subnets towards the network so that the rest of the network doesn't get overwhelmed.
If you like this video, go to ipspace.net/cloud to explore other overlay virtual networking webinars.